Hey everyone! Ever wonder why some code fixes look perfect, but still cause problems down the line? It's like a magician's trick. Everything seems to work, but the real magic is hiding in plain sight. Today we're pulling back the curtain on a groundbreaking AI tool called RePaCA that's changing how we spot these sneaky, overfitting code patches. Let's dive in. So here's the problem. When developers fix bugs, automated tools sometimes generate patches that pass all the tests but don't actually solve the real issue. These are called overfitting patches. They're like a band-aid that works for one test case but fails in the real world. Traditional tools either take forever to check these fixes or miss the subtle flaws. But RePaCA, it's smarter, faster, and actually thinks like a human. Here's how it works. RePaCA uses a large language model, the same AI that powers chatbots, to reason through code. Instead of just guessing, it walks through the problem step by step. For example, if a patch adds a super specific condition to pass a test, RePaCA will point out, this only works for this case. It's not a real fix. Or if a patch handles a rare edge case like none values in code, it'll say, this is a general solution perfect. The secret sauce? Reinforcement learning. Think of it like training a student with feedback. The AI tries different reasoning paths, and when it gets it right, it gets a reward. Over time, it learns to spot overfitting like a pro. And here's the kicker. RePaCA doesn't just say yes or no, it explains why. That transparency is a game changer for developers who need to trust the system. The results? RePaCA crushes the competition. On a small dataset, it hit 83% accuracy and an 84.8% F1 score, a huge leap over older tools. But the real test was on a massive dataset with 50,000 patches. While other tools struggled, RePaCA stayed balanced, with 72.7% accuracy and a strong 72.3% AUC. It's not just fast, it's reliable even when faced with new, complex code. But why does this matter? As software grows more complex, automated tools are essential. Without checks like RePaCA, developers risk deploying fixes that work in controlled environments but fail in the real world. This isn't just about catching errors, it's about building systems that adapt, learn, and reason like humans. Here's the deeper insight. RePaCA's success hinges on its ability to simulate human-like reasoning. Traditional tools rely on rigid rules or brute force testing. RePaCA, however, uses a transformer-based architecture to parse code semantics, identify logical dependencies, and predict long-term implications. For instance, it can detect if a patch introduces a brittle fix by analyzing how changes propagate through a codebase. Let's break it down. When RePaCA evaluates a patch, it doesn't just check if tests pass. It asks, does this change align with the original intent of the code? This requires understanding not just syntax, but the semantics behind it. For example, if a patch adds a conditional to handle a specific input, RePaCA might flag it as overfitting if the logic doesn't generalize. Conversely, if it addresses a root cause, like a null pointer vulnerability, it'll recognize the broader impact. The training process is equally fascinating. Researchers used a combination of supervised learning and reinforcement learning to teach RePaCA. They fed it thousands of labeled code patches, where each was tagged as overfitting or general. Then, they simulated real-world scenarios where the AI had to choose between multiple fixes. Over time, it learned to prioritize solutions that balanced specificity with robustness. Essentially, the same trade-offs human developers make. This isn't just academic. In practice, RePaCA has already identified critical flaws in open-source projects. One example, a patch that fixed a memory leak in a specific test case, but introduced a race condition in concurrent environments. Traditional tools missed it, but RePaCA's reasoning engine flagged the inconsistency, prompting a more thorough review. Looking ahead, tools like RePaCA are part of a larger trend, AI systems that don't just execute code but understand it. By combining large language models with reasoning frameworks, researchers are building tools that can debug, optimize, and even refactor code autonomously. This isn't about replacing developers, it's about empowering them with superpowers. So the next time you update an app, remember, behind the scenes, smart code is working hard to make sure your tech stays smooth, safe, and, well, not crashing. Thanks for watching and stay curious.